So here's an outline as to how differentiation takes an equation of a graph and turns it into a formula that gives you the gradient anywhere on that graph. So here's an equation of a graph, and it's got three kinds of things in it. It's got things with powers, things that doesn't have powers, and plain numbers like this. And this is how they differentiate. This is how they are turned into a formula to work out the gradient on such graphs. So if you have things with powers, all you do is just take the power forwards to the front and times it, and take away 1 from the power, and you get this. So this kind of stuff turns into this kind of stuff in the formula for the gradient for equations of graphs like that. So you basically take the power forwards and take away 1 from the power, and you get that. NaX to the power n minus 1. And if you got a number with a number times an x, so if you got like 5x, that just differentiates to 5. Or if you got minus 1.2x, that differentiates to minus 1.2. So just get rid of the x and keep the number. And if you differentiate a plain number, that just disappears and becomes a 0. You don't need to write plus 0 in the real working out. This is just showing you that numbers differentiate to nothing. And so as you can see, what you do to differentiate an entire equation, you take its individual bits and differentiate them separately and put them together to make an entire formula. So dot 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 over here, by the way, means you can have all sorts of things that basically look like this, this, or this, and you differentiate them according to one of those three rules, and then you put them together to make an entire formula. So that's how you differentiate. And just looking at this formula, which basically starts off with a dy by dx, I talked about that in an earlier video. Basically that just means the gradient of a graph that has the equation that looks like this, y equals something with x in it. That formula that gives you the gradient anywhere on the graph works according to any x coordinate on that graph. So if I've got an x coordinate that is, say, 5, 6, so the x coordinate, if I've got a coordinate that is, say, 5, 6, the x coordinate is 5, therefore, right? The first thing in that coordinate. And you put that 5 into your formula and, times it and do it to the power and all this kind of stuff and do the rest of it to it. And that will give you a number, and that will be the gradient at that x coordinate, that point on the graph. This stuff here, by the way, is just another way of writing this. So if you, instead of having y equals stuff with x's in it, a function of x, you just write fx. If you got fx instead of y, then when you differentiate, you write f dash x instead of dy by dx. This kind of alternative notation. That's it. These are equivalents.